If the source is in rest and observer is in motion, just now we have derived an equation, that is when if the source is at rest, observer in motion, then according to the time period, then we can do that when moving away from observer moving away from the source, means just now in this case source is at rest, observer is in motion. For method 2, according to the time period, we can derive the equation, that is method 2. Means source is at position at S, is at rest, so the source velocity Vs is equal to 0. Then observer is at a distance of L from the source. When the source is at a distance of L, source and observer both are at a certain distance. Whenever observer is moving away from the source at a point to the O dash, he is moving with velocity V0. V0 means observer's velocity. So here is the observer's velocity V0, that is he travelled at a distance of V0 T0. Distance is equal to velocity into time. So V0 T0 means V means observer's velocity V0, and T0 means the time taken to travel from this point to that point, that is T0. So here is that consider here the source and observer at a distance L, and here is that at a time t is equal to 0, the source has produced one wave, that is the first wave. The time taken by the observer to receive, that is T1 is equal to L by total distance L by from this point to this point. Whenever observer is at this point, he received first wave, that is L by, the distance will be the L and the velocity will be when the source is at rest, but the total velocity of sound will be V. Is the sound is moving with same velocity, then that is V plus V0, because observer is also in motion with the velocity V0, so that's why L by total velocity will be V plus V0. And if in case of after some time observer travelled certain distance in time T0, T is equal to T0, observer travelled some distance, that is V0 T0, distance is equal to, distance will be total length L plus distance travelled V0 to T0, so L plus V0 T0 be the distance that the observers travelled. So after some time he received another wave, that the distance L plus V0 T0, then the second wave has received by the observer, that is T2 is equal to T0 be the time taken to travelled by an observer from O to O dash, plus the time taken to receive the observer, that is L plus V0 T0 by V plus V0. Then after travelling some time, T is equal to 2T0 time, then the third wave has received by an observer, that is T3 is equal to 2T0 plus L plus 2V0 T0 by V plus V0. Means here the L plus V0 T0 by V plus V0 is the distance by the travelled by the wave. Means at the starting from S to the total distance travelled L plus V0 plus T0, L plus V0 plus T0, L plus V0 T0. So that's why L plus V naught T naught distance traveled by the wave. So the time taken to travel the observer plus the time received by an observer from the L point to the reached point O dash, L plus V naught T naught by V plus V naught. Then this is the third wave after traveling sometime 2 T naught, means here is the O double dash, it is 2 T naught, means here is the 2 V naught T naught. Okay, then the total distance has traveled. So we are writing that for n times the observer n distance traveled, so that's why n T naught will be that. Then whenever after traveling n times n T naught distance, then the crust received by the observer is n plus 1th wave. N plus 1th wave has received by an observer after traveling n T naught times. So here Tn plus 1 is equal to n T naught plus L plus n V naught T naught by V plus V naught. Further, the total time taken to receive the waves by an observer is the time t is equal to Tn plus 1 minus T1. Tn plus 1 minus T1. Then a time period capital T is equal to small t by n, that is equal to Tn plus 1 minus T1 by n. Here is that the total value begin. Then the time period t is equal to, what is Tn plus 1? Tn plus 1 means n T naught plus L plus n V naught T naught by V plus V naught, means n T naught plus L plus n V naught T naught by V plus V naught minus what is T1? T1 is equal to L by V plus V naught. So L by V plus V naught. From that equation, then we can write that here is the denominator taken separately to the L and n plus V naught T naught. Then we can get n T naught plus L by V plus V naught plus n V naught T naught by V plus V naught minus L by V plus V naught. Here is that we are writing the denominator to the L and n V naught T naught separately, then we can get the equation. Then from that equation we can write that the L plus L by V plus V naught minus L by V plus V naught get cancelled. Then from that T is equal to n T naught plus, in the both terms n T naught is common, so we are taking outside, then n T naught, then 1 plus n T naught taken outside, so that's why that remaining V naught by V plus V naught, V naught by V plus V naught. So here if we compared with the velocity of an sound of a observer's velocity, the observer velocity is very small, which can be negligible. So that's why here the V naught is very less than if we compared with the velocity of a sound. So that's why V naught is less than V. So V plus V naught is equal to V. We can write that similarly equal to V. V plus V naught is equal to V. From that equation, when we can write that T is equal to n T naught of 1 plus V naught by V. 1 plus V naught by V. Already we know that by n is there. By n is there in total terms. So by n is there, we are cancelling n. We are cancelling n. So here that n is there in the total terms. So we are cancelling that denominator n and numerator n, that get cancelled. Then T is equal to T naught of 1 plus V naught by V. Then from that, but apparent frequency nu is equal to 1 by T. Here nu is the apparent frequency. Then from that, here nu is equal to 1 by T, then nu is equal to 1 by T means 1 by T naught, 1 by T naught plus T naught of 1 plus V naught by V. V naught by V. We know that 1 by T naught is equal to same as nu is equal to 1 by T. Like that, mu naught is equal to also 1 by T naught. So we can write that nu is equal to nu naught of 1 plus V naught by V. 1 plus V naught by V. Here is that 1V inverse, because of whenever taken to the numerator, the denominator taken to the numerator, inverse sign will get. So that's why from binomial principle, from binomial principle we can get that 1 plus x power n is equal to 1 plus nx. If we compare with this 1 plus v naught by v whole power minus 1 with this, then we can get the equation is from 1 plus x power n is equal to 1 plus nx, we can get the equation is here nu is equal to nu naught of means 1 here plus minus 1 into plus minus in this position x position v naught by v is there, so that's why we are writing that v naught by v. This is the equation for when the source is at rest and observer is in motion towards the source, then we can get the equation here is that nu is equal to nu naught of 1 minus v naught by v. Means whenever the observer is moving away from the source, not towards, away from the source. When observer away from the source, if in case of if the observer moving towards the source, then if observer moving or approaching the source or approaching the source, v naught becomes minus v naught. So here is that if we write that minus, nu is equal to nu naught of 1 plus v naught by v. Here is the equation for an apparent frequency of whenever the source is here moving towards the observer is nu is equal to nu naught of 1 plus v by v. If in case of source is observer is moving away from the source, then we can get the equation nu is equal to nu naught of 1 minus v by v. Here is that about that Doppler effect when the source is in motion, source is at rest and observer is in a motion. Thank you.